Let's review ethers. Remember to apply those organic chemistry skills, identifying structural features and reactive sites as you've done before. Ethers are found in biomolecules. They're also used as solvents. Note that they're unreactive, and they're also used in anesthetics. Crown ethers are an interesting type of ether. Note that they serve as the host to metal ion guests and allows metal ions to be transported where it's hard to transport them. Although ethers are used as solvents, care must be exercised in storing ethers because they auto-oxidize to peroxides and can explode. Note that the ether group is similar to the alcohol group. The only thing we're doing is replacing an H with a C. So stop the video and answer these 3 questions. The answer to these questions are on the next slide. So note that ethers are bases, and ethers can undergo substitution reactions. So ethers are prepared from either alcohols or from alkyl halides. See practice problem 3. Check out this reaction making the ether. So Tylenol is used to make phenacetin, another pain reliever. So stop the video and answer these 2 questions. So ethanol is used as a solvent. Sodium hydroxide reacts with the alcohol group to make the alkoxide ion. Then the alkoxide ion reacts with ethyl iodide in a substitution reaction to form the product. Ethers are also prepared from alkenes, so stop the video and draw the intermediate in each reaction. So the intermediate is a carbocation. The reaction on the left goes to form a alcohol and see practice problem 4 for the reaction on the right. So let's apply those organic chemistry skills to substitution and elimination reactions. So stop the video and draw the structure of the product of each reaction. Using curved arrows helps. So the reaction on the left is an elimination reaction, and the reaction on the right is a substitution reaction. So remember to identify those structural features: alpha carbon, H bond, beta carbon, and leaving group and nucleophile. So let's apply your organic chemistry skills to predict the product of each reaction and to identify the reactants to make the ether in those 2 compounds. Note also that NaH involves a hydride, which is a base. For the first reaction, hydride reacts with the alcohol to form the alkoxide ion. Then the alkoxide ion reacts with either the alpha carbon or the H bond and beta carbon to form the substitution or elimination product. In the second reaction, see practice problem 5a. For the synthesis problem, start from either an alcohol or an alcohol and alkyl halide. So here's one way to do that synthesis. For the second synthesis, see practice problem 5b. Now that we know how to make ethers, we can see how ethers react. So stop the video and describe the mechanism of this reaction. So remember that ethers are bases. We just made the ether into a better leaving group, and now the nucleophilic bromide can react with the alpha carbon, while the leaving group leaves. Note the second product should be CH3OH. Remember that practice makes perfect, so stop the video and predict the product of each reaction. Remember to identify those structural features. For example, note that there's 2 alpha carbons on the first compound. So after protonation, the bromide can react at either of the alpha carbons to form either of these alkyl bromides. In the second reaction, there's only 1 alpha carbon. The carbon in the aromatic ring is not considered an alpha carbon. Protonate the ether first to form methyl bromide and the alcohol phenol. The last reaction is similar to the first reaction. Protonate the ether first, then bromide can react to either alpha carbon to form an alcohol and alkyl bromide. Phenacetin is no longer used as a pain reliever because of safety reasons, but it can be converted to acetaminophen, so stop the video and determine what reaction conditions you will use. So remember, ether is a poor leaving group, so make it a better leaving group. So there's 2 alpha carbons, so react a nucleophile at one of the alpha carbons to give the desired product. HBr works well for this one. So let's apply your organic chemistry skills to predict the product of each reaction. Remember to use curved arrows to show bonds breaking and forming, so stop the video and work on these for a minute. For reaction 1, there's the substitution product, but you can also show the elimination product. For reaction 2, the alcohol is deprotonated, and then it occurs a substitution reaction to form an epoxide. For question 2, the first step is a Grignard reaction to form an alcohol. And the second step, remember that Br2 behaves like an electrophile. The alkene reacts with the Br2 in an electrophilic addition reaction. And the third step, KOH is a base, and it removes the proton from the alcohol. Once that proton is removed, it reacts with the alpha carbon in a substitution reaction. And then the last step is an elimination reaction to form the product. The glycosidic bond in sucrose is an ether. So stop the video and show how sucrose is hydrolyzed to glucose and fructose. So protonate the ether first, then react it with water to form glucose and fructose. Note the new OH bonds that form in each molecule. So more practice, see practice problem 7, and even more practice with the synthesis of naproxen. So stop the video and answer these 3 questions. So the base deprotonates the alcohol, then a substitution reaction occurs with the methyl chloride. The second step is a Grignard reaction, except the Grignard reagent reacts at the alpha carbon in a substitution reaction.